For this next example, we've got a b value of 1/2, which means the parent function on this one is y equals 1/2 to the power x. So for this function, I'm starting out with exponential decay because the b value is between 0 and 1. So let's go through the transformations on this one. That 2 that's in the front is an a value. Since it's bigger than 1, that's going to make it a vertical stretch. In the exponent, the x was replaced with x plus 1, so that means the h value is actually a -1. If you think about the x plus 1 in there, that means that it's moving left 1. And then at the end, we have a k value of -3, so that means we're moving down 3 for all of our points. Okay, back to the parent function now. The horizontal asymptote is at y equals 0. The horizontal asymptote is not affected by the a value or the h value in the transformations, but it is affected by the k value. So since that's a -3, that means that our horizontal asymptote would be y equals -3. I'm going to use that to sketch the graph now. So starting with a coordinate plane, I'm going to put in my horizontal asymptote. So y equals -3. So that would be somewhere down here. I'll draw that in and then I'll label it -3, and then it must be. And I'm going to do the same thing I did last time. So I'm going to put in the y-intercept from the parent function, and then I'll make all of these transformations happen to it to find the next point that I'll put on my graph. I think I'll do it in light blue. Okay, so when I do a vertical stretch, that's going to affect my y value only of my y-intercept. So I'm multiplying the y value by 2. So 1 times 2 is 2. So now it's at 0, 2. Now if I move to the left 1, that's going to affect my x value. So I'm going to subtract 1 from the x's. So now I'm at -1, 2. Then if I move down 3, that'll affect the y value. So I'm going to subtract 3 from the y value only. So that would put this new point at -1, -1. So I'm going to go ahead and put that on my graph. -1, -1. That pink line that I drew in was at y equals -3. So -1 should be a lot closer to the x-axis than that. Okay, now once again, this one, in order to figure out how the curve goes, I would need to know whether the parent function was growth or decay. This one is decay, which means that as I go to the right, the graph needs to get closer to the horizontal asymptote. And as I go toward the left from that y-intercept, it would need to go away from the horizontal asymptote. So this would be my graph now. Now I'm looking at this graph to determine whether I've got growth or decay going on here. As I move from left to right on the graph, altogether, I see that the y values are going downward, so that makes this decay. The domain, once again, for these exponential functions, the domain is completely unaffected by any of our transformations there. So it's still all real numbers. And the range is either everything above the horizontal asymptote or everything below the horizontal asymptote. Looking at my graph, I can see it's everything above. So I would say that this is y is greater than -3. Okay, now you try the next one on the Google form.